Now we want to learn to convert between the moles of a compound and the mole of its constituent elements, because every compound is made up of different elements. So what is the number of moles of oxygen and 18 moles of carbon dioxide? How do we do that? Well, we've learned that chemical formulas can be used as conversion factors, just like if we have one spider, we know it has 8 legs, or one chair has 4 legs. If we said, okay, we have 2 spiders, that means we have 16 legs, right? And this is similar because we know for 1 mole of carbon dioxide, it's made up of 1 mole of carbon and 2 moles of oxygen. And we've just figured that out using the subscript here right after that. So, what is the number of moles of oxygen and 18 moles of carbon dioxide? As usual, we always start with what we're given. So we have 18 moles of carbon dioxide, and we want to know how many moles of oxygen. Well, for every 1 mole of carbon dioxide, since that's on the top, that's going to go on the bottom, we have 2 moles of oxygen. And so the moles of carbon dioxide cancel out, and we have oxygen, and that would be 36 moles of oxygen. Okay, now determine the number of moles of oxygen and 1.7 moles of calcium carbonate. Okay, and we do the same exact thing. Here we see that in 1 mole of calcium carbonate, we have 1 mole of calcium, 1 mole of carbon, and 3 moles of oxygen. So, if we have 1.7 moles of carbon or calcium carbonate, then we know for every 1 mole of calcium carbonate, we have 3 moles of oxygen. Okay, and this gives us 5.1 moles of oxygen, since the moles of the whole calcium carbonate cancel out. Okay, now I want you to go ahead and give this a try. Determine the number of moles of sulfuric acid this time if you have 5.6 moles of oxygen. So we're going to go the other way around. Try to see if you can figure this out and then replay the video. Okay, so we always start with what we're given. 5.6 moles of oxygen, okay? Now we see that for every 1 mole of sulfuric acid, we have 2 moles of hydrogen, 1 mole of sulfur, and 4 moles of oxygen. So, since the moles of oxygen is on the top, we're going to put moles of oxygen on the bottom. So there's 4 moles of oxygen for every 1 mole of sulfuric acid. Okay? So you see, it doesn't matter how the problem is phrased, as long as you start out with your given number and then you just flip that conversion factor depending on which one will cancel out. So here this will cancel out, and we end up with 1.4 moles of sulfuric acid. Okay, now we want to learn to convert between the grams of a compound and the grams of the constituent elements. And this finally we have our tools to solve our sodium problem. Remember, the FDA recommended that we get 2.4 grams of sodium per day, but we don't ingest sodium alone because that's poisonous. We get our sodium intake from sodium chloride, which is our table salt, right? So we want to know the mass of sodium that we're getting if we ingest 15 grams of sodium chloride that day. We always start with what we're given, which is 15 grams of sodium chloride, and we want to know how many grams of sodium there is in that. But we can't go directly from grams of sodium chloride to grams of sodium, because the chemical formula gives us a relationship between the moles of a substance, not the grams. Okay? Remember, this is like comparing apples and oranges. We have to convert to the mole, which is our common unit. It's the chemist's dozen. So 1 mole of anything is got the same number of particles. So that is why we have to go to moles first. So you must convert to moles of a substance before using the chemical formula as a conversion factor. And so that's why we're adding this step. So we want to go from grams of sodium chloride to moles, and we use the formula mass for sodium chloride that we calculate from the periodic table. So that we have 58.44 grams of sodium chloride for every 1 mole of sodium chloride. Now we can use the chemical formula as a conversion factor. For every 1 mole of sodium chloride, we have 1 mole of sodium. Okay? Now we want the mass of sodium. So we go back and we do this step here by converting from moles of sodium to grams. And we have 1 mole of sodium is 22.99 grams, and that's just its molar mass of sodium looked up from the periodic table. And we get our grams of sodium chloride canceling out, our moles of sodium chloride canceling out, our moles of sodium canceling out, and we are left with grams of sodium. So we have 5.9 grams of sodium. Okay, now let's do another example. Carvone is the main component in spearmint oil. It has the pleasant aroma and the mint flavor that is often added to gums, liqueurs, soaps, and perfumes. So we want to find the mass of carbon in 55.4 grams of Carvone. And let's see here that I gave you the chemical formula for Carvone. I don't expect you to know that. So we want to go from grams of Carvone to how many grams of carbon in that. And we want to start out with grams, and we want to go from grams of Carvone to moles of Carvone, because remember, you have to convert to moles in order to use the chemical formula as a conversion factor, right? So we have 55.4 grams of C10H14O, which is Carvone. And then we want to go to moles of Carvone. So we look up, and I gave you here the chemical or the formula mass, which is 150.2 grams per 1 mole of C10H14O. Now we can use the chemical formula as a conversion factor. Well, we know for every 1 mole of Carvone, just look at this chemical compound as the whole, and we are trying to find the parts in a whole. So for every 1 mole of C10H14O, we have 10 moles of carbon, right? Now, we want to go from moles to grams, because that's what we're asked to find, the mass of carbon, not the moles of carbon. So we say, okay, 1 mole of carbon will give us 12.01 grams of carbon. And you see how the grams here cancel out, the moles of Carvone cancel out, the moles of carbon cancel out, and we end up with 44.3 grams of carbon. So if we have 54.4 grams of Carvone, 44.3 grams of that is actually carbon. Okay, now I want you to give this a try. I want you to determine the mass of oxygen in 5.8 gram sample of sodium bicarbonate. So we always start with what we're given, and we have 5.8 grams of sodium bicarbonate, okay? And we want to figure out the mass of oxygen in that. Well, we can't do that yet because we're in grams. We have to convert to moles. Because remember, the chemical formula is saying there's 1 mole of sodium. For every 1 mole of sodium bicarbonate, there's 1 mole of sodium, 1 mole of hydrogen, 1 mole of carbon, and 3 moles of carbon. It's not saying for every 1 mole of sodium, or it's not saying for every 1 gram of sodium bicarbonate there's 1 gram of sodium or 1 gram of hydrogen. We're speaking mole to mole. So we know we're going to use the formula mass of sodium bicarbonate, which is 84.01 grams per 1 mole of sodium bicarbonate. Now we're ready to use the formula as a conversion factor. So we know for every 1 mole of NaHCO3, there's 3 moles of oxygen. And we don't stop there because we want to know the mass of oxygen. So for every 1 mole of oxygen, I have 16.00 grams of oxygen. All right, you see now my grams cancel out for sodium bicarbonate, my moles cancel out, my moles of oxygen cancel out, and I'm left with grams of oxygen, which is exactly what I'm looking for. So I get 3.31 grams of oxygen. Don't forget to round. Well, this would actually be 3.3 because we have 2 significant figures here, okay? And our units, grams of oxygen.